Welcome again to this series on IMTA. Today we are going to finally discuss IMTA in the 21st century. So in the previous episode we learned that in the 1970s there was an interesting research discussion on the cultivation of different species in a waste recycling type of system. This was called polyculture type of system. It was followed by 3 productive decades on what has been variously called ecologically engineered aquaculture, and then it was ecological aquaculture, it was simpler. Also, integrated mariculture was a name that came across some researchers, but then again, this is not only about marine animals, so another name came up and it was integrated aquaculture. Well, understanding the need to harmonize all these names, in 2004, Thierry Chopin and Jack Taylor combined integrated aquaculture and multi-trophic aquaculture into the term integrated multi-trophic aquaculture. But what is all this about anyway? Well, the classic 21st century approach and Western concept of IMTA is to grow fish, here you have the salmon, invertebrates like mussels, mainly bivalves, and also seaweeds, mainly kelp. This type of approach was usually associated with salmon cage aquaculture type of systems, but the key thing about IMTA as a concept is that the appropriate organisms to be cultured are chosen at multiple trophic levels based on their complementary functions in the ecosystem as well as their economic value or potential. But what does multiple trophic levels exactly mean again? Well, let's see this in an expanded version and in more detail of the IMTA concept. So in this example, we have several trophic levels. We have the feeder species, the fish in this case. Then we have what we call the extractive species, which in this case include both organic filter feeders, like the mussels and scallops. These are generally bivalves. And we also have inorganic filter feeders, the seaweed, in this case they're kelp. But we also have the deposit feeders, everything that is on the bottom of this ocean floor. I mean the sea cucumbers, the sea worms, we also have sea urchins over here. Those are deposit feeders. But how does this work and why is it important? So remember the model approach with inputs and outputs? This is kind of similar. So let's start with the fish. The feeders. So the fish are fed and as a consequence they usually grow. But they also produce feces and other wastes such as nitrogen. On the other hand, some of the food is not eaten and settles to the bottom. This can be nutrient inputs for the other trophic levels. So let's see what happens in detail. For instance, let's see what happens with the kelp. So basically what we see here is that it's a bigger version. So we have the fish, they produce the nitrogen under different forms, and the seaweeds can use this waste, this nitrogen waste, this nutrient for them and grow. That was this part of the system here. So I want you also to have a look at this system over here. It's also important to bear in mind that this nitrogen is not only feeding the seaweeds, it's also feeding microalgae that will also feed mussels. Let's have a look at the microalgae. So nitrogen and phosphorus, they also are a nutrient source for microalgae. The image in itself, it's a green bloom of microalgae in the ocean. This is just a kind of zoom in of the microscopic microalgae. And probably you've seen this in your aquarium if you have one. And one way to get rid of these microalgae is if you have a seawater type of aquarium, you can actually add mussels, because mussels they're going to eat that microalgae. So mussels are called filter feeders because they can filter that small organic particles, as I mentioned, the green microalgae. You're going to see them in this time-lapse video with mussels in an aquarium. This is the microalgae, the green thing. They filter, the water gets clear, and they expel the pseudofeces and feces. this will settle, in this case, in the bottom of the aquarium. They would settle in the bottom of the ocean. They also excrete the nitrogen, just as fish and other animals. You can't see this in the video, of course. So this is the muscle bit of the equation. Let's look at the deposit feeders then. The deposit feeders use the organic particle nutrients, the uneaten feed and waste, also decayed matter for nourishment. And I don't have a video specifically to show you the bottom of the ocean with the sea cucumbers and sea worms and lobsters all eating decayed matter and uneaten waste. So I will have to give you a link to BBC One, and this link is for the Frozen Planet, which is an amazing series, and there is an amazing time-lapse image. So I'll just show you one of the images from Frozen Planet. Bear in mind, this is not what the bottom of a salmon cage looks like. These species don't even exist in the habitat where the salmon cages are. And this is just to show you what deposit feeders and scavengers can do in the food chain in trophic level context. So after watching this tutorial, go ahead and click the link, and I hope you'll enjoy the BBC One Frozen Planet time-lapse video. So at this point I need to tell you that IMTA is not just this that I've been showing you. IMTA is more than just mussels and salmon, and it was never conceived to be only this type of species, or even to be only used in temperate waters and within a few 100 meters. So IMTA is also a concept that can be like aquaponics, like the production of vegetables and fish. This is a system that is a mixture between hydroponics, so the production of vegetables in a water system, and aquaculture, the fish here. And it can be a small system like this one. This is an artistic, and it was a concept proven by an artist. It was actually built, and it really looks like this, and they do have fish in this tub. And so it can be as small as this, and it can be as big as this. So this is a renewable energy park. This is a wind park. There is the energy production here, but there is also the farming of kelp, of deposit feeders and other species over here. This is fully integrated because it also integrates different professions. Unlike we have the fisheries here, we have fishermen that can take advantage of this system, and we have also tourism, and we also do need to have research vessels and research in general to monitor this system. So there are many people involved in this. So for today, this is what I have to show you. It's still in what I did and what I mentioned was basically the concept. So on the next spot, I will be talking about IMTA put into practice and from the business point of view. So I hope you can join us.